Hello chemistry folks. For today, just watch this example video for maybe just understanding how to set up a problem and solving them. And just a quick few reminder before you do the first three, once again, the first 3 page of the work package that is going to be handed out by Mr. Lawman. So number 1, see what you're given and what you're looking for, right? So in this case, I know liter is going to be volume. So V1 equal 190.0 liter. I know pressure, clearly say pressure, P1 is equal to 200.0 kPa. P2, what is the pressure? I don't know because it said what is. That's going to be my question mark. At a volume, because liter means volume, V2, because we use V1 of 130.0 liter. So from that, we're going to use this equation because it has P and V in it. And that's what we'll have. So let's plug it in. P1 V1 equal P2 V2. P2 we don't know, so we leave that as P2. I darken it up so I know it's not just a unit. And V2 is 130.0 liter. And cancel out the liter on both sides. Cancel out the 0. Probably cancel out the 0 too. So now I divide both sides by 13 to get P2 by itself. And whatever you do on one side, as we said, do the other side. So I grab my calculator, I punch it out really quick. I have 200 times 19, because the 0 already cancel out, equal, divided by 13. And my answer is roughly 292. So over here, all I have left is P2. The unit left is kPa. And the number when I punch it out is 292.3. Just keep 1 or 2 decimal places. It's up to you. Next one, pretty similar. Once again, just list out what you have and what you're looking for. So I know liter is volume again. So I know V1 equal 8.50 liter. I know pressure is ATM, so P1 equals 6.00 ATM. What is the volume? So I know V2 is what I'm looking for. And pressure of 10, so that means P2 equal 10.0 ATM. So PV, once again, we use the same equation because it's PV, so we plug in P1 V1 equal P2 V2. And you can go V1 P1 equal V2 P2. It doesn't matter when you multiply which way. So 6.0 ATM times 8.5 liter equal 10.00 ATM times V2. That's what I'm looking for. So I darken that up. Now let's see what I can cancel out. So I have 8.5 times 6 equal 10 V2. But I don't want 10 V2, I want V2, so I divide both sides by 10. And what if I do on one side, I do onto the other side. So V2 equal, the only unit left is liter. And if I punch it out, roughly about 5.1. Circle both of my answer. And that's what I expect you to do on the first page or so of the worksheet. And the same thing pretty much apply for the second page. So just FYI, it's not how many problems you do, it's just follow that same procedure. So on this one reminder is all temperature has to be in Kelvin. So to go from C to Kelvin, all you have to do is take the temperature in Celsius and add 273. If you want to go backward, temperature in Celsius will be temperature in Kelvin minus 273, okay? So those are the equations we took in our notes today. Let's use them. So let's read. A sample of gas has a volume. So we know V1 is 0.713 liter. Even if it doesn't say the word volume, we know liter is volume, right? At a temperature, so that means T of 200 Kelvin, because we know Kelvin, Celsius, or temperature. What volume? That means V2 is what we're looking for. And it is at 30 degrees Celsius. So T2 is 30 degrees Celsius. You cannot compare apple to oranges. So one is in K and one is in C. We both need to turn them into K. So to get them to K, you only have to add 273. So we punch that out. 270 plus 30 is 300, bring back to 303 Kelvin. Okay, so we'll plug that in. So the equation I pick obviously is this one because it has V and T in it, right? So V1 over T1, V1 is 0.713 liter over T1, which is 200 Kelvin, equal V2 over T2. We don't know V2, docket that up. Divided by T2, which is 303 Kelvin, because we can only compare things in the same unit. Cancel out the Kelvin. Now just cross multiply. 200 times V is leading to 200 V2 equals 0.713 times 303. I'm going to need a calculator for this. Roughly 216. Roughly. Okay, and within that circle, you notice there's a liter in it, so liter. And it makes sense that we're looking for volume, we have liter. So to get V by itself, I gotta get rid of this 200 by dividing it by itself. And whatever we do on one side, we do onto the other side. So V2 equal 216 divided by 200, roughly 2. No, it's not 2. 200 divided by 2 will be 1.08. Okay, I'm doing it without a calculator, so if I'm off by a little bit, but it should be close to 1 and slightly bigger. And how do I get 0.08? 16 divided by 20. I mean, I'm not 16 divided by 20. 16 divided by 2 is going to be 8. Okay, so circle that. 1.08 is answer. The last one I'm going to do as an example is this one. So we read it again. We have a volume V1 of 4.5 liter. T1 is 25 degrees Celsius. We might as well just add 273 to that right away, because we have to be in Kelvin for any gas calculation, since you cannot have a negative answer for volume or pressure. So that's just the rule. Okay, V2 clearly said 80 liter, and we know liter is volume. What is the temperature? So T2 is what we're looking for. So follow the same equation again up here. V1 4.5 liter over T1 298 Kelvin equal V2 divided by T2, which we don't know. Cancel out the liter. The only unit we have left for temperature is Kelvin. Makes sense. Cross multiply. 4.5 times T2 is 4.5 T2 equal 298 times 80. It's going to be probably double. That's going to be pretty big. I can't do that. So let me get out a calculator. And it tells me 23840. And the unit within that is Kelvin. So now divide both sides by 4.5 to get rid of the 4.5. But whatever you do on one side, do on the other side. That's a decimal. I'm not going to try to do that in my head, so let me punch it out. And I get 297.77 repeating, and the only unit left is Kelvin. So no matter what the question is, just take the time to read, to go forward or backward. For temperature, you just add 273. So just a little side note. Pretend I have a temperature in Kelvin, say 309, and I need to change it back to Celsius. What would that be? So I take 309 minus 273, and I get 36 degrees Celsius. For Celsius, you need the degree sign. For Kelvin, you do not. So once again, your job is to do the first 3 pages of the package, okay? Just the first 3 pages of the package. Do not go on to the ideal gas law, because we have not learned that yet. Have a good day. See y'all back tomorrow, or Thursday technically.